And so when we kind of think about those use cases, which is this ability to compose or join things from not just within the same system, but across systems, and that ability to talk over an API instead of talking over, say, SQL, what does that mean for your users, for the use cases that you folks are seeing?
I think what often users don't realize, right, and this is why I'm excited about what you're announcing today, is that if you had a layer that could seamlessly just query the data where it is to create exactly that answer back to them, that is so powerful. You don't have to now create these complex pipelines and sync jobs. And I think many users are just unaware that it's possible, that it's that simple. And so what they ask me for, is something much, much more complex. So I'm very excited. I think it's a really powerful use case for my users.
What Hasura gives you is a layer of governance and responsibility and interoperability that kind of imposes the right patterns, right? So you mentioned this, Tanmai, right? If somebody changes the schema somewhere at the source, right? I shouldn't have to wait until some chart sees it, later in the evening. The system needs to be able to handle these types of scenarios. So I think that's really exciting.
For 3 reasons. Disaster recovery, because we moved to the cloud, we made it cheaper, but we also made it highly probable to fail, because that's the nature of the game. The second reason is, you have global users and nobody really cares about the sob story of how difficult it was to build. If it's not quick, I'm going to the next service. That's really the consumption mentality. Now, the third one is the government's got in and said, if a person from country X, makes a transaction on a server stored in country Y, whose data is it? So there's 3 reasons, and app development gets complex, and that's where this layer also can bring a lot of superpowers. At least this is more from a transactional perspective. So.
And all our panelists, feel please jump up on the stage. I appreciate it.
Hello.
Hey. Thanks for joining us, Tino and Tanya. So great to have you, and so great to meet you. I know we've been interacting. I've been interacting async via people, so great to see you in person.
Hello, happy to be here.
Thanks for having
us. Karthik.
Hey, Tanya.
Cool, awesome. So, just as a to get kind of the conversation started, I'd love for us to go around the horn, do a round of introductions. Please do introduce yourself, or tell us a little bit about kind of the company, the technology, and then I'll kind of seed a few more conversations as well. But would love to kick that off. Tanya?
Sounds good. Thank you so much. My name is Tanya Bragin. I'm head of product at a company called ClickHouse. We are an open source analytical database. I'll talk maybe about the technology in a bit, but my background really has been primarily in product. I started off in a customer-facing set of roles, but I've been in product management for the past decade, over a decade, previously at Elastic. So really kind of open source driven data companies. That seems to be my sweet spot and what I enjoy.
That's awesome. Tino?
Hi there. Thanks for having me, as always. I'm Tino. I help out. I'm a co-founder and head of product at MotherDuck, and we're kind of a new breed of analytics company as well. And I basically spent the last decade building Google BigQuery. And it's funny because I used to joke that BigQuery likes to go after the really, really big customers, hundreds of petabytes. And I used to joke, I don't get out of bed for less than 100 petabytes. But I think now we're looking kind of like swinging in the opposite direction, right? There's just so many people who have, the vast majority of users don't have that much data, and they're just kind of not being heard. So we're trying to address the needs of these folks.
That's absolutely amazing, Tino. Thank you. And Karthik?
Hey guys, also one of the co-founders and currently the co-CEO. I was before the CTO, but I had a lot to do with product. So I'm not like exactly in different company here. So product is what I identify with of Yugabyte. So we are an open source transactional database. So still open source, but a slightly different database compared to you guys. And by way of background, mostly been in engineering. So I was at Facebook and ended up building and open sourcing what is now Apache Cassandra, HBase, including running these databases in production. So I was also exactly like Tino. We wouldn't get out of bed for anything less than a petabyte. It's like, it's too small. I mean, come on, really want us to do all this work for so little. But I do agree with him. Like, the data set sizes I mean, we're probably dealing with data set sizes slightly bigger than the ones that you're dealing with, Tino, but nevertheless, it's hundreds of gigabytes to 2 petabytes still. So, but anyway, great to be here. Thanks for having me, Tanmai.
No, that's all. Thanks for being here, folks. It's just absolutely lovely to be in this conversation where we have a variety of kind of databases and use cases. And maybe one of the first things would be I'd love to ask you folks, right? When you think about almost kind of the origin story of how your database technology came to be, tell us kind of a little bit about that, and also in your favorite use cases that you have seen so far of the database technology being put to use, right? So or a little bit on your origin story and a little bit about kind of a color on some of the favorite use cases that you're seeing with your users and with your customers. And maybe this time I start with Karthik.
Sure. Yeah. So yeah, in terms of origin, obviously I'm sure the others will relate, but the $1 million question has always been, why the hell are you building a new database? So, and even worse, why are you starting a database company around it? So anyway, that was ours at least. And so funnily, like I was giving in my intro, the first time we had to answer that question, we didn't really answer it. We ended up building the database. It was called a peer storage development system, which was a mouthful. And they said, that's too long. No one can remember it. Just give it a name. And so we ended up naming it Cassandra, right? And that was the first time we did it. And it was to make sure we could handle data that wouldn't fit on a single node. So federate queries, federate data. And it was fully open source and it took off and we never thought it would. And, then the next time we did it, it was because, we found that a large variety of applications could be built with single row consistency. Cassandra was eventually consistent. And so we ended up building HBase, but it was operationally very hard and we gave up some availability properties, right? And the third time we did it in Facebook, and this time it was too hard to open source it, but we went ahead and did it anyway. So this was for SSDs and zones and regions and the cloud, right? Like more. But we retained the properties of Cassandra, scalability. We retained the properties of HBase, single row consistency. And it was a RocksDB interface. And so the applications would build into it, right? And then when we looked at the enterprise, we said like, yeah, this is too hard. Enterprise applications cannot move. So the bottom line was we wanted to build something that would work in zones and regions for SSDs, AKA cloud native architecture for transactional applications built on relational databases. So ergo, we said Postgres on top, keep it the way we built a lot of these databases at the bottom and, simplify the way people build cloud native applications. So there it is. Our mission was to simplify, mission critical data in the cloud native world. So use cases, well, there are a lot of interesting use cases. I think the interesting piece about YugabyteDB is even though we're a small company, obviously, when you go after transactional databases, which is mission critical data, and resilience and availability, which is what we offer, and the ability to scale, that attracts some of the biggest workloads in the world, right? So we do have a lot of very, very interesting workloads we're proud of, like a bunch of e-commerce companies like run their product catalog on us. There's like, for example, General Motors running their entire smart vehicle platform on top of us. So like anytime you do that, emergency 911 call, remote key fob entry, all of that stuff goes through Yugabyte. Across, like a lot of banks are using us to deal with user transactions for, and data resilience in the cloud and so on and so forth, right? So we have a bunch of these type of use cases. I would say the most interesting one is we're seeing a trend towards dispersion of data across the globe. For a variety of reasons, like there's reasons for DR purposes, there's reasons for moving data closer to users for easy access. And like, I mean, think about it, right? Like any of these retailers like Kroger, Walmart, these guys are all using us for product catalog. I mean, they do let's say PlayStation 5 launch, they did that, right? The amount of spikes are like, Apple releases a new iPhone or any of these events, the level to which they see spikes is unbelievable, right? Like it's like a 1,000 times higher. So they have to prepare for these events. Like we recently did the Paramount Plus Super Bowl, which was the largest streaming event. And we were the database that authenticated users to be able to get onto that feed, the live stream. These, like the 2 hours before, it's just an incredible spike. So it's like everyone's like watching the graph and like, it's going up, it's going up, it's going to stop, it's going up. It's kind of crazy. Like halftime, the Taylor Swift show, all of these are spikes. So I think that is categorically the most interesting type of workloads that we're facing, where you can go up and come down and you have to deal with these super high spikes.
That's awesome. I love that. Tino, what's the origin story? What are your favorite use cases that you've been seeing over the last few years?
Yeah, and of course, I'll try to be as brief as Karthik. So we are an analytics data warehouse. So we're slightly in the OLAP space. But there's a really interesting trend that everyone's really hungry for analytics. And you're seeing more and more of the application developer, software developer type personas dipping into analytics because there's more hunger for analytics-driven applications, data-intensive applications. And they're kind of, the analytics space is kind of doesn't give them the tools they want. They don't, they speak SQL instead of APIs. And, this is one of the reasons Hasura is so interesting. And so, but really what we've, the reason we started MotherDuck is we think that there's been a number of really interesting trends that the current analytic data warehouse doesn't really take advantage of. One of them being that my MacBook, which is actually an M1, is just as powerful as a $20 cloud data warehouse per hour out there, right? So, it's free. I've already paid for it, and it's 0 milliseconds away from me. And it's just as fast as this big old black box in the cloud. And guess what it's doing? It's just a dumb terminal, right? It's just saying, hey, cloud data warehouse, give me a couple of rows. That's just a waste of massive opportunity, right? So we at MotherDuck said, you know what? This amazing technology, open source called DuckDB, can go anywhere. You can put it in the browser. So we said, let's put it in the browser and let's push workloads away from this big black mainframe in the cloud. And now you're getting, your DuckDB in your browser and your is a node in our system. And it's, again, 0 milliseconds away, already paid for. Now we're talking about, not of this performance differences of 1 second, 100 milliseconds. Now we're talking about potentially analytical experiences that are truly interactive, 24, 60 frames per second. And so that's kind of a big thing we're double clicking on. The other is, I kind of pointed out, the current kind of way of building these databases is, again, like putting up a big monolith and all the users are sharing, they're all bumping elbows. And application developers don't really like that mode, right? And that's why you're seeing like Cloudflare, for example, they say, you know what? Why don't you deploy 20,000 databases, 50,000 databases, one per user? So we want to do the same thing for analytics, right? So what we're giving our users is a serverless runtime per user. So if you as an application developer, if you have 1,000 users, each one of them gets their own isolated serverless runtime that's incredibly efficient and incredibly inexpensive, right? That's kind of a new world that hasn't been tried in analytics before, but in transactional worlds, you're seeing these trends. And a favorite use case, goodness. So I really, really like this intersection of analytics and software, right? It's just untapped. You guys are talking about local development. Nobody in analytics is doing that, right? You guys are talking about this cat's cradle, these microservices. Nobody in analytics is doing that. So I just love it.
Great. I guess the best for last. Like Tino and MotherDuck and DuckDB, ClickHouse is an analytical space. Just maybe to define it for the audience. So analytical data is fundamentally different from transactional. It's append mostly. Usually it's an event table. This is exactly the kind of data I was dealing with at Elastic. So in my role there, I was responsible for the logging and eventually observability use case. What was interesting about ClickHouse, it's an open source technology, just got open source in 2016. By 2017, I was hearing from my customers about this amazing database where they were seeing, 10x benefits, both in terms of resource consumption and thus cost, as well as performance. And they started moving away from Elastic. And it wasn't because Elastic was a bad database, but it's because ClickHouse and technologies similar to it really realized that when it comes to structured analytical data, you can, in fact, have this very disruptive resource and cost structure. Elastic was really an expert at search, at semi-structured data, but if you know the structure of your data, ClickHouse was delivering much better benefits. So maybe going back to kind of where ClickHouse was born, it was really originally developed for web analytics use case, thus the name, ClickHouse, Clickstream Data Warehouse, but then quickly expanded to marketing analytics, product analytics for folks like me, eventually observability, right? So logs is just events, traces are just events. So we're seeing both those use cases. But what's more interesting, and Tino, I think alluded to it, the world of data warehousing is absolutely getting transformed. I've recently written a blog on this about unbundling of the cloud data warehouse. There's definitely been a lot of innovation that came from that technology, but now that all of this data is in the cloud, there's a lot of interesting opportunities for where it could go, what kind of architectures could be there. So we're seeing some interesting use cases there as well for internal teams. And finally, you really can't get away from AI ML in not only Gen AI spaces. ClickHouse is often used as a feature store. There's a lot of structured data out there. Big, medium, small, really doesn't matter. But structured all-up data stores and analytical data stores like ClickHouse are really a great use case for that. So yeah, and ClickHouse Inc., we're the company behind ClickHouse. Our main focus is serving both the open source community as well as building a cloud offering around it.
Got it.
Yeah,
no, that's awesome.
I think the both of us, I think Tino and I should have also mentioned about the open source and cloud. Yeah, so
all de facto open source only here. So this
okay, never mind. Okay.
But no, that's great. Thanks everybody. I think when we kind of start to think about, and this is what we've been noticing and what some of you alluded to as well, right? Is like we see this kind of the world of data and API and software development colliding, right? Especially with AI and ML, where it's getting very confusing what our usual personas used to be, right? Where we had a data analyst who would like do things, but now they're also the engineer who's building something. And are they accessing it in an analytical way or a transactional way or a data retrieval for AI kind of way, right? Which is, it's slightly different beast. It's been very interesting to see kind of those ideas collide together, right? Everything from the way that we deal with a large amount of API sprawl, where you kind of take ideas from the data catalog ecosystem a little bit, right? To this idea of composable access, which is an idea more from SQL, where can I query what I want as opposed to the API pre-deciding for me what it should give me, right? And the two kind of central ideas here is, one is the idea of data access over an API. And the second is the idea of being able to compose that, meaning that get data from multiple places to kind of hydrate that API, right? And so when we kind of think about those use cases, which is this ability to compose or join things from not just within the same system, but across systems, and that ability to talk over an API instead of talking over, say, SQL, what does that mean for your users, for the use cases that you folks are seeing? And maybe Tanya, you can kick it off.
Yeah, absolutely. So as I mentioned, analytical databases are for events, but they're not used in isolation. In the end, those events come from somewhere, usually the fundamental data that would be used to generate some of that activity. For instance, a product catalog or a customer catalog will be stored in a transactional database, whereas the events, especially at high scale, may go into a more specialized database like ClickHouse. But in the end, what users want is they want to get results from both, right? They may have a product ID and an analytical database that they need to join with metadata that is, where the source of truth is a transactional database. Now, what users may ask me for is say, hey, Tanya, I really want change data capture from your database of choice, and I would like to duplicate this data and keep it in sync, and we'll support that. But if you think about it, that lift of like creating these sync jobs, it's really, really high. And actually, one of the sort of roadmap items for me is like how much down the rabbit hole do I want to get into sort of supporting all of these flows right inside my technology. There's third-party technologies out there. I think what often users don't realize, right, and this is why I'm excited about what you're announcing today, is that if you had a layer that could seamlessly just query the data where it is to create exactly that answer back to them, that is so powerful. You don't have to now create these complex pipelines and sync jobs. And I think many users are just unaware that it's possible, that it's that simple. And so what they ask me for, is something much, much more complex. So I'm very excited. I think it's a really powerful use case for my users.
No, thanks a lot, Tanya. And I think it's the same, like it's interesting, right? Because right now it feels like the only available solution for us is to ETL data from one place to another. And like you said, that's very expensive to not just set up and like make that data move, but also to operate, right? It's like your governance and modeling, and something changed in the source, and like, does that field being captured or governed or secured and like complied with appropriately as it comes into the sink? And it's an expensive process. And many times you might need to do that, but many times you just don't. And sometimes you don't know. So sometimes maybe you start with saying, well, let it be in different places. And if I need to, for whatever reason, I'll figure out how to move it to a different place. But to maintain like a consistent API while doing that in the background, while improving performance or while solving for certain kinds of data residency problems as we need to, right? I think that becomes an extremely powerful idea, right? And helps us kind of like leverage data where it is ASAP, but then also know that like we have the flexibility to do whatever without affecting our end consumers. Tino, when you think about kind of like these API use cases or composability use cases, what speaks to you, and where do you think it's relevant for your users and the kinds of use cases that you want to enable?
Yeah, I think it's interesting because for the longest time, people used to say, well, just throw it in the data lake and then we'll sort it out, right? And I think people are becoming more mature, more responsible with things, thanks to better tooling. And, like Tanya, you came from observability, you know this better than anyone, right? That it's a necessary evil to have this layer on top that kind of acts after the fact, that even identifies that things are broken. What Hasura gives you is a layer of governance and responsibility in the interoperability that kind of imposes the right patterns, right? So you mentioned this, Tanmai, right? If somebody changes the schema somewhere at the source, right? I shouldn't have to wait until some chart sees it, later in the evening. The system needs to be able to handle these types of scenarios. So I think that's really exciting. There's really another brand new pattern that I'm seeing, and I've heard it be called compute on data. And it kind of plays into the world that we're building together as well. And it's the fact that, yes, like moving data in order to make it useful is an artifact that's going away. And actually keeping data what it is the more sensible, again, thanks to better governance, better tooling is the most sensible way of doing things, more efficient way of doing things, right? The problem thus far has been, if you try to do that, you get this cat's cradle that you can't manage, right? So with the announcements today, I think that will make things better. But the other aspect of compute on data is deploying things like, I've seen this with lots of customers these days, deploying things like this tiny DuckDB runtimes everywhere in your environment, and using that for analytics, using that for really kind of like small ETL, small reduction of data. Because at the end of the day, sometimes the way data looks in Postgres is not the same way you want it to look, to the end user, right? So sometimes it's unavoidable to do a little bit of transformations.
No, that makes a lot of sense. Karthik, coming from a very different world on kind of more transactional than analytical, when you think about kind of these API capabilities, and composability capabilities, right? What kind of speaks to you for your users?
Yeah, I'll maybe start with the composability capability, right? I would say the YugabyteDB, it sits right on the other side of the table, right? So everything that, I think at least you were mentioning, Tanya, on everything your users ask you guys, or I'm sure same for you, Tino, about how to ingest, they ask us about how to export, right? And so the kind of headache we have to deal with, I mean, not a headache, it's all good stuff, but you know what I mean, is like, can you give me a stream? Can you make it least impactful on that transactional database? Because, anybody sneezes around the machine, they have a heart attack, because, that's what it is. It's like money on the line every second, every missed operation. So how do you do this with the least amount of, overhead on that cluster that's running or serving your, live traffic? And oh, by the way, there can be network partitions. So how do you actually hold data for a long time? And oh, wait a minute, you need more resources if you hold data for a long time? Okay, can you give me a staging cluster that can hold data, that can really isolate stuff? And yeah, that's a lot of data now that builds up, like you were saying, Tino. You start doing this stuff, pretty quickly it adds up because you made it easy, and now it really adds up. And no one wants to pay more than they're making. So then it's like, can you give me that filter that I can push down on the CDC stream, which goes to the new thing, which retain? I mean, you know what I mean, right? So it keeps going, right? It's a huge ecosystem in itself. Like we try our best to integrate with partners. We try to leverage the commonality of what people can do. So wherever it's not needed, it's a lot more efficient. Like I mean, you're right, Tanmai. Ultimately, it may be needed in a bunch of cases, and it absolutely should be used the way all of this is worth it, right? But in the cases where you have to do it because there's nowhere else to, no other way to do it, it's kind of a shame. It's like building a lot for that small thing that you wanted to do. So composability aspect, absolutely. I think it's pretty exciting. At least people can tiptoe their ways in to realize when they need to build the big machinery versus when they don't. So, that's a huge plus. There's also a pattern. I mean, I don't know if this flows under the API side or the composability side, kind of in the middle, but you mentioned GenAI, ML, that type of workloads. It's kind of a fast-moving stream of data. Some of the AI falls in the transactional space, and some of the AI computation falls in the analytical space. It perfectly straddles it, right? And it just depends on the depth of the computation versus the real-time nature of the results, right? So it's kind of like it's really that, right? And this is what I guess some people would say Lakehouse or Delta Lakehouse or whatever it is, and just like abstract away. But in reality, you need a more lightweight but real-time component to it, and a heavyweight but it can be a little slower and be more accurate component to it. The lightweight things, they usually run directly on the transactional database, easy, no problem, right? But the heavier weight ones, those are the problem, right? Now you need to flow back the results of that computation back to this system. Now, do you really need to flow it back, or can you just read it from there and pick it up? I think these are patterns that we haven't really thought about, and it is actually becoming more of a secular pattern. It's not exactly uncommon to do deep analytics on one side and use the results or some portion of the results on the serving side. So can you fetch it from there? Is it updated often or not? Like, whatever, right? So I think there's a pattern there that to unlock. And finally, I'll come to like what I was saying was, I think the more on the transactional, this is completely on the transactional API side. APIs, I think quite a fair percentage of them are used on top of transactional data. And so what we're seeing is like, firstly, all of this just simplifies your access to the data, because, ultimately no one accesses the APIs at the highest level as raw SQL. It's always through a ORM or some layer that is used to build a REST API, which is then used to consume it from either a mobile phone application or a desktop application or some other downstream system or all of the above, right? So invariably, there's always a API component that comes in, and making that cookie cutter, making the security and the observability and the scalability, availability, all of that is super critical. And flipping this around, right? What Hasura does to the Postgres data, we kind of extend it down into the database side of the stack for the OLTP data, right? Like make it available and scalable. And the last thing that we're seeing is also data being distributed all over the place, right? For three reasons. Disaster recovery, because we moved to the cloud, we made it cheaper, but we also made it highly probable to fail, because that's the nature of the game. So that means now you have to do extra work to make sure if it fails, you can do something about it. And so that brings about dispersion of data, the first reason. The second reason is, you have global users, and nobody really cares about the sob story of how difficult it was to build. If it's not quick, I'm going to the next service. That's really the, consumption mentality. Now, I'm probably doing the same thing, but you know what I mean? So, so that's a second. And then the third one is the government's got in and said, if a person from country X, makes a transaction on a server stored in country Y, whose data is it? And so they said, like, this is not even worth fighting. As many countries have said, my data for my people have to be in my country. So this unfortunately means that if a single person goes on vacation to a different country and comes back, where do you store the data? Well, it turns out you got to store 5 transactions here and 50 transactions in the other place and blend them and do all of this stuff. So there's 3 reasons, and app development gets complex. And that's where this layer also can bring a lot of superpowers. At least this is more from a transactional perspective. So
no, that's awesome. I think that speaks to kind of this idea that if we are kind of seeking to commoditize these infrastructure capabilities, right, so that people can get on with the business of business building, then being able to for vendors like us and for the entire industry to be able to solve those problems in a way that we have to deal with the headache of understanding what government regulations to support, and developers can just kind of build things, right, is the future that we all want to move towards, right, from a developer experience and developers building the future kind of perspective. We're almost at the close of our session, so I'd love to end with what are the items that are coming up on your roadmap over the coming quarters, maybe over the year, that you'd like to talk about, that you're most excited about, Especially if it's relevant on the kind of API real-time consumption side, that'd be great. But even otherwise in general, right? What are you most excited about this year on your roadmap? Tanya?
Yeah, absolutely. So I already mentioned the use case around feature store, which has been pretty fundamental to use of ClickHouse in kind of data science type organizations, training models. The new capability we're working on this year, it's already experimental, is vector search. And this is something that Karthik mentioned more on the serving side, using embeddings to sort of complement your other analytical queries. So you may have like a fraud analytics use case. You already use aggregations to kind of answer the question of like, is this transaction fraudulent or not? You may want to add an embeddings-based component to it. So doing that straight in one database is a pretty powerful thing in the analytics space. The reason this is relevant to this conversation, we often get requests, just take a SQL query and turn it into an API. And this is for speed of prototyping. This is just to make a developer team move faster with a different skill set and not writing boilerplate code. This comes up all the time. So even outside of cross-domain join, just what you have at Hasura is so powerful. I'm sure my users don't want to take some feature that I built for this purpose. They want to use a technology that works across different domains, across different databases. This is coming up more and more for us. Everybody wants to move faster, and time to market is everything.
Yep. This is absolutely true, right? I think I think this business of like, if I've done my hard work in choosing a database and in setting it up well and in doing kind of the data modeling at that layer and doing the transformations and whatnot, like, why do I need to build the API? Like, can that be free? Can that be as free as possible, right? And no, that I think speaks to all of our users and resonates with kind of the speed at which people need to be doing things. Tino, what about you? What are you looking forward to this year on your roadmap?
Well, we're actually quite new, I guess. Our first version of our product came out less than a year ago, so we're driving towards general availability. So a lot of really boring things, right? Just the things required to actually even call yourselves a production grade data warehouse is really important. But I think the things that are really exciting for us is are all the things as Tanya pointed out, right? Like developers are really exciting. There's probably 10 times as many developers as there are analytics experts. So it's as analytics is dipping into its toes into that space, we're seeing that the ergonomics that we've provided over decades are insufficient. So APIs, right? SQL is not as fun. But also there's other opportunities, right? We've talked about WebAssembly being a new frontier. And you guys talked about local development being a new frontier, right? Again, like this big cloud monolith that you can only talk to, through these asynchronous calls. You can't do CI/CD with that, right? So we're double clicking on that as well.
That's awesome. Karthik, what about you? What's cooking?
So for us, I'll say three things. I'll mention three things. The first one is, of course, we are working on, vector capabilities as well, like a lot of demand on that side. And our work is to disambiguate what exactly vector means for the enterprise and, actually take all of the capabilities and map it to, real use cases and figure out how to do that in a scalable, available manner. So because, we ride on the Postgres ecosystem a lot, we are fully Postgres compatible. So it's really about, understanding the details under the hood while making it look the same above. That's pretty much our journey, actually, most of the time. So that's that. So that's one. I think the second one is, we've been putting in a lot of effort into, we are already able to nearly lift and shift simple Postgres workloads. And, those people that are setting up to migrate from other databases to Postgres, we can kind of seamlessly laterally move them to Yugabyte and give them the ability to have built-in resilience and scale when they need to. So we already have that, but we're making that easier with a migration toolkit, like because while Postgres has a migration tool and a script and a library, it has too many of those and too many, you do a different thing for Oracle, you do a different thing here, you do a different thing. And after a while, even we're like, what the hell is all this? Like, let's just throw it all in and put the if condition somewhere else and, just figure it out automatically. So that's one. And the third bucket, I'd say, which is pretty exciting, is places where we need to go, like people are pushing us for their use cases beyond Postgres. So this is like DR with built-in replication, asynchronous and synchronous, or like point-in-time recovery, or seamless upgrades and downgrades, or or even connection management, where the number of connections and the speed of connections that we can handle, like on a single node by building in a connection pooler. So a bunch of those type of features where, it's ultimately not Postgres, it's not the layers in between. It's like, just support the app and that's it. Like, is that too much to ask? So cloud native applications have a pattern which develops an ecosystem around traditional databases. And, when you try to really think through them from an architectural standpoint, you have to not stick it, but you have to build it into the new database. So yeah, so those will be the three things, I think.
No, that's awesome, folks. I think over the next few weeks, as we're kind of rolling out our connectors that are specialized for Yugabyte, for MotherDuck, for ClickHouse, I'm really looking forward to kind of like incorporating some of these ideas that we've discussed into reference architecture, so that people have kind of a way of thinking about, if I'm building this kind of a thing, this is what that architecture looks like. This is how I can build an application, test it out, scale it up, etc. And as kind of we get the developer community kind of moving and excited about and educated about how to use kind of some of these new ideas that you folks are at the frontier of, I think it's just going to be absolutely amazing year. This is, I'll call this to a close, but you folks are on the social handles and the LinkedIns, and we'll have links to that we'll post for everybody who's attending the call and everybody who's watching the recorded session. Thank you so much for joining me, three of you. It was great meeting some of you again. It was great meeting some of you for the first time, and I look forward to all of the awesome stuff that we all have planned.
Thank you for having us.
Thank you.
Amazing, man. Thank you so much, Tanmai.
Thanks, folks. Bye.